Hi everybody. So my name is Giulio. I'm a researcher at IBM, and in today's talk we're going to go over red teaming LLMs. We're going to give a focus to one of our open source projects, Aries, but also give a bit of a general flavor of the area and the kind of problems that you encounter and difficulties there, and maybe hopefully encourage you to use Aries to assess the robustness of your LLM systems. So why red team LLMs? Now with LLMs being deployed and beyond kind of just chatbot applications and being used as coding assistants to call MCP tools in business critical workflows, the security and robustness is becoming more important. When they were just limited to perhaps chatbot applications only, it was perhaps more limited, the damage that a subverted LLM could do. Like it could be mean to you, for example, it could say offensive things, but it was unlikely to cause immediate dollar damage if the expected workflow was hijacked. Now I think they're being used so widely in so many different situations that the story is a little bit different. And so there's been a lot of efforts into trying determining how robust LLMs are to arbitrary hijacking by adversaries. This is kind of building on previous research in robust machine learning. This isn't a new field that's just emerged with the rise of LLMs. This has been going back many years, but now with the rise of LLMs, it's really matured, I think, from going just from a pure academic and pure research exercise to now actually having a lot of practical real-world use cases. Now we're dealing with real hijacking and with real systems rather than just academic papers. The general flow with these things, at least traditionally, is you have some human red teamers try and probe an LLM and find some weaknesses. And generally speaking, I think if any of you guys get given access to an LLM with a chatbot interface, odds are without too much effort, you'll all be able to hijack it and break it and subvert the safeguards. The difficulty here, I think, is twofold, which introduces the motivation for more robust tooling. Is one, a case of scale. We're not particularly interested when doing these kind of assessment evaluations in finding just one jailbreak or one prompt hijacked. We want to be able to systematically discover classes of them and find thousands of them to train downstream detectors and safeguards and guardrails. But then also the second one is a difficulty of what kind of jailbreaks and hijacks will humans find naturally just by prompting the model. You'll find certain classes of data distributions and types of attacks, but humans won't naturally generate classes of attacks that are based on like optimization techniques. A human will never find these seemingly random token strings that algorithmically you can start finding. When you run these evaluations, there's a couple of things that you need to try and consider. Partly is how can an attacker interact with your system? Like, is it just, as we've been discussing, through pure chatbot interactions, like, okay, you type something into a text box in a screen, or is in your particular system, your LLM relying on MCP tools that could have hijacks inserted in them? RAG documentation that has been manipulated in some way, or now there's skills, which gives like another potential attack surface for an adversary. These are all potential injection points that an attacker can start interfering with. So it really depends, like in your system, what is relevant. The more points there are, there's more things to check. It's unlikely you'll be able you'll have some kind of budget with these red teaming exercises. So you need to motivate your red teaming exercise with the attacker model for your system. And here it's also important to distinguish between the attack strategy and the attack objective. So the attack objective is, what is the attacker actually trying to obtain from your system? So this could be some malicious code, for example. It could be trying to subvert the tools that are being called. On the other hand, the attack strategies, algorithmically what's going on behind the scenes for the actual subversion of the LLM workflow. And it's important to distinguish with them because sometimes they get mixed up, but this is kind of a cross-product kind of search that you need to do, which is where some of the scaling problems come in. Here's like an example plot, right? Like you can have lots of different types of attack objectives, like write me some code, some malware code, leak some private information, whatever it might be. And there can be many, many different attack strategies. So if you just check like a single class of attack strategy, like the crescendo attack, Great, your model might be very robust against this attack and related attacks in that family, which are based on like using LLMs in a attacker kind of role-playing scenario. But you might miss like optimization-based attacks, which your model might be weak against. So this cross-product is something that you need to kind of consider when doing your LLM evaluations. And again, this scaling problem is something that then motivates like having a good attacker model. Like for you, what is important? And what will inform your defense design the most when you're running them? Because unless you have infinite budget, which you rarely do for security, you're going to need to pick and choose and deploy the safeguards appropriately. When you do run this, and there'll be, when you start running these tools and you start jailbreaking your LMs and you find these weaknesses, map these risks that you find in these jailbreaks to known risks and threat models. There's lots of different kind of things that you can use here to start gauging the severity potentially of these things and mapping them to what is relevant in your use case. I think it's something to bear in mind, like not all threats are equal in this. If your LLM does not have access to private information, then the fact that it could, in theory, leak it is not maybe something you need to consider. So, like, what does your threat model in this situation say? A very generic, all-corners threat model that says, like, okay, I just want my LLM to be robust against everything and never do anything bad is not very helpful in the design and a strengthening of the system. Be specific, because that's then ultimately what's going to inform the research, design, and development of your safeguards, and which is ultimately what you want to try and improve when doing these red teaming exercises. These safeguards will always obviously have some kind of overhead, some kind of costs, be it compute costs. There could be like false positive rates go up. So you need to deploy them in a manner that actually extracts the maximum amount of benefit for you and your system based on the kind of risk profile that you have and the vulnerabilities that you find in your LLM. So hopefully this gives a bit of an overview of the kind of state of play here. So to try and do all of this kind of stuff, there's been a wide range of tooling that's been developed and deployed. A lot of it is open source, some of it is closed source. So kind of some projects that have emerged out of the open source ecosystem are some of these ones. We're going to focus on our own one, but this is just to highlight. There's a lot of work going on here. And a lot of these ones have some great aspects to them. So, by all means, have a look at some of these things after the talk. They might be what you are after. But we think, anyway, that they have some shortcomings, which is where Ares, which is our system, hopefully tries to improve. Some of these kind of difficulties that some of these tools have is around mapping some of the attacks that are included to known threat models like OWASP or NNIST or MITRE risk frameworks. Some of them are have variable evaluation methodologies, which makes comparison between different attacks difficult. They can have various difficulties in terms of deployment and scaling and customization. So what are we trying to do differently with Ares, and why do we think it's a good approach to the problem? So Ares, fundamentally, we're trying to motivate it with the idea of modularity. So Ares has a very small, lightweight core component. So at its core, there's just 4 small bits, which is the glue that holds the overall red teaming pipeline together. So there's the target, which is like the actual endpoint that you're trying to test. The goal, and so this is, okay, what are the attackers trying to actually achieve here, and how can we expand and enrich this data distribution to have good coverage? The strategies, which is where the actual attacks live, and finally the evaluation. Outside of these 4 components, there's then the plugin ecosystem, which we're developing. This plugin ecosystem should lower the barrier to entry, because if you have a contribution that you want to add to it, it can essentially live independently of the rest of the system. And can also mean that you can tailor Ares to your use case very specifically. You don't necessarily need to load 100 different attacks and deal with the overhead of managing that overall software system if you just have some specific things that you want to try and test for in your threat model, in your risk profile, and so you just need to deal with that. So to go into some of these components in a bit more detail, we'll drop the target because the target is essentially just some lightweight glue to talk to the various models that you might be loading, and go into maybe the more interesting components, which is the goals, the strategy, and the evaluation. So the attack goals, at the core, they're going to be some seeds that you have that represents the high-level intent of the attacker. So this can be like, okay, generate me some malicious code, but you want to scan for more than, for example, that just that one particular prompt. So this can be variations on that intent, different styles of like attacks that you can run within particular attack families. This can also cover things like not just, say, domain-specific behavior in terms of malware, but also like, okay, well, what if your LLM is interacting with different tools and RAG documentation and and different types of backend? So you can have lots of different like goals here that specify what are possible things that an attacker might want to do, or I would like to prevent from happening at a high level. We then have the strategy, which is where all the actual like mechanics live, the algorithmic components that run. So this can be different kinds of attacks, from obfuscating the attack request, running some kind of optimization, composing different strategies together, running multi-turn attacks, so gradually steering conversations in particular ways. And so these are largely based on like different academic papers and research that's been going on to really try and give you the breadth of coverage you need to have a good idea of how robust your LLM system is. And finally, there's the evaluation. And the evaluation one can rely on a few different methods, from relatively simple, lightweight methods, like just doing string matching on the output, to more involved and more lengthy analysis based on LLMs as a judge and variations of it, or specific plugins based on, say, checking for privacy leaks and risks. The evaluation is kind of important because the LLM's outputs can be so varied that actually having a consistent and robust evaluation pipeline is one of the difficulties actually in having this. If the LLM's output is in itself obfuscated, then you need to have like a good way to check that actually what you're doing has been successful or not, to get a good idea of how robust the actual underlying system is. So, when you boot up Ares, you will see something like this, so we have a few different ways you can interact with Ares. There's like a CLI, there's some APIs that you can code up in Python directly, or we have this nice GUI interface where you can drag and drop different configurations and load up the plugins you want. So there's kind of hopefully something for everybody to use the system. We'll give, in the last couple of minutes, an overview of maybe when you run Ares, what might you want to try and do for and check for. So this is, for example, based off a hackathon we ran a couple of months ago, where we set up an intentionally lightweight small system that we can run attacks against. So in this scenario, we have an agent which can have some tools, and what the attacker is trying to do is say like, hey, give me some information that belongs to a different user. The LLM should refuse this request, and what the attacker is going to try and do is break this alignment. So here's, for example, like what should happen. We say, hey, what are my recent transactions? The LLM calls the appropriate tools and returns you, okay, this is what you bought recently. If you ask, hey, give me the transaction of a different user, it says the alignment is correct, and says like, hey, I can't do that because you're not the right user. When we can run like one of the Ares attacks in this scenario, which called Crescendo, which is a multi-turn attack. So here what happens is the attacker LLM will gradually steer the conversation, starting from like an innocuous question, and gradually persuade, let's say, the LLM that's being subverted to reveal the information you want. So here eventually we get the transaction IDs for this different user. Obviously, this is like a simple demo system. We've used Aries much more extensively than this, both on like open source systems, but also closed source internal systems to really like show the different scenarios that we can deploy Aries in. The final outputs that you can get is that looks a bit like this. So you have an overview of the goal, which says, okay, I want to hijack the system and get some information that I'm not supposed to obtain. The final prompt that actually triggered the attack. This is the final one in the whole conversation. And then the final LLM response, which actually gives the user ID and the tool call response. And finally is the evaluation. So like in this scenario is a relatively straightforward kind of evaluation output where you say like, okay, well, the user is not user ID 2, but you will get in more borderline cases which maybe need more reasoning on the part of a LLM evaluator why a particular output was considered malicious or not. So Aries is in active development. We are open to PRs, issues, try it out. We have a good suite of current attacks and evaluation pipelines, but we're expanding them all the time. We've tried to make it, like I said, lower the barrier to entry through this plugin-based approach. So if it's something you are interested in, by all means, check out our GitHub, give us a star, and try and use it. So thank you very much for the time. We're on the dot exactly, so if we've got time for any questions.
Perfect. So thank you first for this presentation, and this is working now. So do we have any question for Giulio? So no, we don't have any question. The same question why it's not in Eclipse. Yes?
Your slide also is in the documentation part in the GitHub?
Sorry?
Can we also find the slides in the documentation in the...
Are these slides in the GitHub?
Yes.
No, these aren't in the GitHub. There might be some way to disseminate them.
Yes, there will be some way to disseminate. After the event, the material will be available strangely in open source way. Yeah. Yes, so it will be available, but as you can see, we have a link in here, so we can connect with Giulio. I think you can write him. Okay.
Yeah. Well, if you're interested in slides, yeah, drop me an email or LinkedIn, and I can email them. That might be easier than waiting for them to be spread around officially, let's say.
Okay.